Alright guys, today we're doing some more Algebra 2 review, and we're going to look at complex numbers. So complex numbers are, if you guys remember, it's imaginary numbers that you learned about in Algebra 2. So imaginary numbers are basically if you have the square root of a negative number. So you guys learned that the square root of -1 is equivalent to I. So basically what that means for us, anytime I have a negative on the inside of a square root, it's the same thing as an I on the outside of a square root. Okay, so if I had something like the square root of -9, I could simplify that to I times the square root of 9, and we know the square root of 9 is 3, so that can just be simplified to 3I. Now you guys also learned that I squared is equal to -1, which means that I cubed, that's the same thing as I squared times I, which is the same thing as -1 times I. And then finally, I to the fourth, that's the same thing as I squared times I squared, which means -1 times -1, which is just 1. Now, if I to the fourth is 1, this pattern will start to reset after the fourth. That means that every I raised to a multiple of 4 is going to be 1. So that means that I to the fourth, eighth, 400th, any of those would be a positive 1. So if I want to evaluate something like I to the 23rd, what I need to do is find the closest multiple of 4 that doesn't go over that. So in this case, that would be I to the 20th. And using exponent rules, I know I to the 23rd is equal to I to the 20th times I to the 3rd. Because if I multiply those two together, I add the exponents. Now, since I to the 20th, since 20 is a multiple of 4, that means that that's the same thing as 1. So I just have I cubed. And we just talked about before that I cubed is the same thing as a negative I. Okay, so the next thing we're going to do is just some operations with complex numbers. So some of the operations we're going to look at, the first one is just basic addition and subtraction. So I's kind of work with like X's in the sense that you have to combine your like terms together. Imaginary numbers can only be combined with other imaginary numbers. So if I were to subtract this, remember I'm subtracting both parts of that parenthesis, which means I'm subtracting 2, and then I'm actually adding 4I. I can combine the real parts together, and then I combine the imaginary parts together. And you want all of your answers to be written, all your complex numbers should be written in the form of A plus BI, where A is the real part and BI is the imaginary part. That's actually what we had written over there. So A plus BI is the form we want our final answer to be written in. Alright, we're going to use a very similar process here. We're going to multiply. So again, when we multiply complex numbers, we're going to FOIL this just like we would if those I's were X's. So I'll do 6 times 2. Plus 6 times 2I times a negative 2I plus 3 times 2I plus 3I times a negative 2I. Okay, so now what I'm going to do is I'm going to simplify this using those same rules. So one thing I know is that I squared is the same thing as -1. That means that a negative 6I squared is the same thing as a positive 6. And now I can, again, combine my real parts together. So my real part is 12 plus 6. And then the imaginary part, I can combine together as well. So again, my final answer is in that A plus BI form. Okay, so we also are going to do, so that was addition and subtraction and multiplication. When you do division, what you're really doing is, it's similar to what you did with square roots. We're trying to get this in that A plus BI format for our final answer. Our final answer should look like that. So what we need to do is multiply by the complex conjugate. So you guys learned the conjugate. The conjugate is basically a very similar thing, but with a different sign. So 3 plus the square root of 3, the conjugate was 3 minus the square root of 3. Okay, so we're going to use that this time with complex numbers. So the conjugate of 6 minus 4I is 6 plus 4I. So I'm going to multiply by that on the top and the bottom. So on the top now, I'm just going to FOIL. So I'm going to do my first times first, my outer, the inner, and my last. And I'm going to do the same thing at the bottom. My first times first, my outers, the inner, and the last. And if you look, the reason we chose the conjugate is because of what happens in the middle here. So in the middle, what we wanted to happen was that I component is going to go away. And we also know that, again, I squared is negative 1, so that's the same thing as plus 16. So now the bottom, I have just a whole number. So the bottom now is just 52. That's the reason why we chose what we did, because when we multiply that out, those middle terms are going to cancel out. Now at the bottom, again, I'm going to combine my like terms. 8i squared is the same thing as a negative 8. So I can combine those into 10 plus 24i. And we're almost done. Now we could simplify this as it is, but what I'm going to do instead, before I do that, is I'm going to break this up into two fractions, which we're okay to do. Because if I were to add these back together, I would still, if I were to add these back together, my denominator wouldn't change, right? Because when we add fractions, we need a common denominator. So I'm splitting it up this way because now it looks like that a plus bi format. And now I can just simplify those fractions on their own. So this simplifies to 5 over 26 plus, let's see, it's going to be 6 over 13i. Okay, now the last thing is just a little thing we need to be careful about. So normally when I multiply square roots, if I were to multiply the square root of 2 times the square root of 3, I can just multiply those inside numbers together and I would get the square root of 6. So if I were to do that here, I would get the square root of negative 2 times negative 5, which is a positive 10. The problem, though, is that that's actually not going to work. That's actually not our answer. And the reason for that, what we have to be careful about here, is when we work with complex numbers, we need to have these in the I form before we actually do that operation. So instead of doing this as the square root of negative 2, I need to turn this first into I times the square root of 2, and I times the square root of 5 before I do that operation. So I don't want to work with a square root of a negative number. I want to work with those i's. Because what's going to happen now when I multiply this, those outside numbers stay outside, inside numbers stay inside, and we learned already I squared is negative 1. So this isn't the square root of 10, this is actually the negative square root of 10. So for the last one here, we're going to apply that same rule. Before I work with this question, I'm going to put all my negative square roots in terms of I. So square root of 3 stays, but instead of a negative square root of negative 4, that's the same thing as negative I times the square root of 4, which we know the square root of 4 is just 2, so we're going to write that as 2i. And then the same thing over here. This is I times the square root of 8, but we know we can simplify the square root of 8, and the square root of 8 simplifies to 2 root 2 times I. And I'm going to have my stuff written this way with the I coming at the end, because again, it's going to look similar to what our final format's going to look like, where it's that A, what our final answer to look like A plus B I. And at this point, guys, it's exactly what we've been doing. We just got to FOIL. So I get the square root of 18 minus 6 square root of 6i. Oops, sorry, minus 2 square root of 6i minus 2 square root of 6i plus 4 root 2 I squared. And I'll go through and make some changes on there. Okay, we know I squared is the same thing as a negative 1, so we're going to change that to minus. And we know the square root of 18 is 3 root 2. So now I'm going to combine the real components together. That's my 3 root 2 and my negative 4 root 2, which gives me a negative root 2. And then finally I have my two imaginary components I can combine together into a negative 4 root 6 I. And it looks like that same form of A plus BI.